Supervised fine-tuning is one of the most powerful but also most dangerous forms of post-training for an LLM. With SFT, you can teach models concepts and reasoning patterns that weren't present in pre-training. So you can transform them from dumb autocomplete systems into like an actually useful assistant. But you always run the risk of completely lobotomizing the model and making it narrowly intelligent on a single task that it's been trained on. At a high level, SFT takes a prompt, like, for instance, what's the tallest mountain in the world, and pairs that with an answer, Mount Everest, and updates the model such that given similar prompts, it produces similar answers. And with enough diverse examples, the model doesn't just memorize the responses, but it actually learns to generalize the underlying patterns. So, at a deeper level, this is done by taking thousands to millions to even more question and answer pairs. And for each example, the model takes the prompt, generates the probability for all of the next tokens. So, think of it as the output, and then compares this against the actual answer using a loss function. So, the optimizer then computes the gradients and updates the model's weights to minimize this loss across many different examples. And over thousands or millions of examples, these localized updates compound into emergent capabilities, which has really brought us from the era of 2018, where we were generating fake but almost real looking articles, to the models of today that are rivaling the world's brightest in math, science, and engineering. But it's not without a catch: catastrophic forgetting. During SFT, you're updating weights across the entire network to minimize loss on your new dataset. And by aggressively updating the weights of the model, you risk destroying existing capabilities. So if you train a model way too hard on coding, then suddenly you might see that it struggles with creative writing. If you train it a bunch on formal language, then you can see that its conversational abilities might suffer. So the key here is balance. Techniques like LoRa, which I covered previously, regularization, or evals to catch degradation early can help mitigate the risk. And if done well, SFT transforms a base model into something far more aligned with human intent.